Hello, so on this episode, we are going to talk about biconditionals and definitions. Biconditional statement is a single true statement that combines a true conditional and its true converse. We're going to talk about further on that definition. Your essential understanding for this is that a true conditional statement has a true converse and can be written as a biconditional. A definition is good if it can be written as a biconditional. So there's some statements here, some key concepts in regards to biconditional statements, and also what we like to call a good definition. Not every definition that we get is a good definition. Okay, and I know that can be a little bit confusing. So I definitely recommend that you read through the problem examples given. All right, now we're going to go ahead and look at our writing that we're going to write for our notes. All right, so definition, the conjunction hold on, I'm spelling that wrong. Cunction of a conditional and its converse. Let me mark what a conjunction means, because I know that's a pretty big word. Basically, it means adjoining. Okay? Now, symbolically, we say P then Q and Q then P. So remember, the converse is Q then P. So we have our normal conditional statement and the converse. We can, if the both are true, so if this is true and our converse is true, we can now write this as a biconditional statement, and we can say P, and then we have this little double arrow, and then Q. We read that P if and only if Q. Biconditional statements are true when both the conditional and the converse are true. So remember, we're going to be thinking about some potential counterexamples, which would make that no longer a true biconditional statement. So our first example that we're going to look at, given the biconditional statement below, two angles are supplementary if and only if the sum of their measures is 180. Now remember, conditional is P then Q, converse is Q then P. So the conditional statement would be written as if two angles are supplementary, then the sum of their measures is 180 degrees. That is a true statement. If two angles are supplementary, then the sum of their measures are 180. Okay, that's written. I've taken what two angles are supplementary, so that's our conditional statement. And the sum of their measures is 180 is our conclusion, our hypothesis. So the two angles are supplementary is our hypothesis. So this is P and this is Q. Okay? Now, I can say the reverse. So we're going to say Q then P. So if the sum of two angles measures is 180 degrees, then they are supplementary. This is also true. So our truth value of this is true. Both are true. Okay, so now let's look at another example. So if I wear my boots, if I wear my snow boots, if and only if it snows. So our conditional is if I wear my snow boots, then it snows. Converse, remember, conditional is P, then Q. So then if it snows, then I wear my snow boots. This truth value is false. The conditional is false. Because if you're wearing your snow boots, it might not snow. So you can't really say that. All right? Now, I would like you to take and pause on the video and try to do 3 and 4 and see how you do, and come back and we will go through it. All right, so I'm going to go ahead and keep going. All right, so the conditional is going to be if x squared is equal to 25, then x is equal to 5. If x is equal to 5, then x squared is equal to 25. This is a false statement, or this is false. The conditional is false. Counterexample would be x could be equal to -5. So, number 3. If, sorry, hold on, let me rephrase that. If I get 10% off, then I spent at least $15. Converse of that, if I spent $75, sorry, that should be 75, not 15. 75, then I will get 10% off. This is true. Both are true. All right. Hopefully that helps you on biconditional statements. In the next video,